In this lesson and a couple of the upcoming ones, we are going to focus on improving the querying capabilities of our REST API. In this lesson, we're going to start by adding support for searching and filtering inside of the DevHabit API. I'll use the habits controller for this demonstration, and we're going to be updating the getHabits endpoint. We want to add support for searching and filtering. Now these two basically achieve the same result. We are giving our API consumers the ability to reduce the number of results that they are getting back. They can do this by applying a set of conditions to the resources being returned by the API by searching for a specific resource or applying some specific filters. Conceptually, the difference between searching and filtering is just semantics, in my opinion. You'll see what I mean when we start implementing this. So let's begin by adding support for searching. Typically, this involves exposing some sort of search parameter on your API endpoint that you can use to filter out the records that you are returning from the API. So let me show you how we're going to implement this. The first thing I want to do is to trim the search if it's not null, and remove any white space. And I also want to convert it into a lowercase string. Then if the string is not null or empty, or null or white space, so I say if string is null or white space, specify our search term. And if it's not empty, then we want to actually perform this logic. Now, how can you implement this? Well, if I go ahead and extract the queryable represented by the habits database set, I'm able to compose some additional operations on it before executing the actual query. So I'm going to define this above our search term. I'm going to also update this to be an iQueryable. And then if the search term is not null or white space, then I'm going to update the query to say where, and then I can define my search condition. And for example, I can say where the habit name to lower contains the search term. And this is how you can implement searching on one property or one column in the database. If I want to support multiple columns, for example, I want to search the description, I can just repeat the same conditions. Convert this to lower for a case insensitive search, and just say contains the search value. Now, because the description is a nullable field, I also have to check that the description is not null and that the search term is satisfied. Executing this step is going to update the queryable, and we are going to chain a few more commands like our select projection and calling toList to finally obtain a list of DTOs. So let's start this and give it a try. If I just send a GET request to my API without any query parameters, we're going to land on this breakpoint, and you will see that the search term still remains null. Then we're going to obtain our query. And because the search term is empty, we're just going to apply our projection and return all of the habits that we have in our database. Now let's say I want to apply my search term and I want to look for this term here, practice. So what I can do is append a query parameter, and I'm not even going to specify the entire word. I'll just include a couple of characters, and then let's send this request. We're going to land on our breakpoint, trim the search term, which contains our value, and convert it into a lowercase string if it wasn't already lowercase. And this time we're going to execute our custom where statement, which is going to apply the searching logic. Then we're going to apply our projection, and we should get back the specific habit that satisfies this search term. Now, if I take a look at the response, you can see I have two of them inside, and if I omit the search term and I send this request again, you will see that we are getting a lot more habits back in the response. I'm not sure how many of them are there in total, but without any filtering, we get a JSON object that is 300 lines of code, and with the search term present, we only get 2 habits back in the response. So implementing the searching logic like this helps us reduce the number of records that we are returning from our API. Implementing your search logic like this in the code makes it easier to figure out where the particular filters are applied, but you don't necessarily have to do this. We could also make all of this be inline. For example, I can take out the where statement that I have here and just paste it here. I'm going to get rid of this, and I'm going to add one more condition in front that's going to check that the search term is null, or it's going to apply my specific filter. Now let's also revert the query to database context and habits, and we are back to almost what we had at the beginning, with our custom search implementation still working the same as before. The next question you might consider is this the proper name for this query parameter? Now there's actually a widely accepted standard, and that is just naming this Q. Now using just Q as your query parameter inside of your code isn't too developer friendly. So what you can do is add a from query attribute for this argument where I can provide a custom name from which I want to bind this value. So now I can use Q when sending my API requests, and this is going to bind to the correct value inside of my controller. Let me show you how this works. If I send this request with the old query parameter name, we're going to hit our breakpoint, and you will see that the search value is null. So let's press continue. We get back all of the habits that we have in our database because we're not performing a search, and then let's update this to be Q, and then let's send this request, and this time you can see that we are correctly binding this value from the query that was sent to our server. So if I press continue, the filtering logic will be applied, and I'm going to reduce the number of records that I'm returning from the database. Now let's consider how we could add support for filtering. Filtering is very similar to searching, except you typically have a predefined set of filters that you can apply. I'll give you a few good examples. Let's say I want to filter based on the habit type, and this value may be optional. So I can specify a type, or it can have a null value. I can also perform a filter based on the status, and then how do I apply these filters inside of my EF core query? Well, we can use a similar logic, and when you have multiple filters, you want to concatenate them. This is the AND logical operator, and it's the same as chaining multiple where statements one after another. So in this case, I want to check that the type filter is null, or the habit type is equal to the type value. And I'm going to add another where statement that is going to check that the status is null, or the habit status is equal to the status filter. So let's start the application and try this out. I'm going to omit the query for the time being, and let's add another query parameter that's going to be my type. Now you can see on this response here that the type value is 2, so let's go ahead and specify that. I can send this query and get a response back that's going to contain all of the habits where the type is equal to 2. Now if I update this to be 1, I'm going to get back just 2 habits where the type is 1, so our filter seems to be working. Then we can add another filter for the status, and what happens if I input a habit status that doesn't exist? For example, something like 10. Well, in this case, we are going to get back a 400 bad request, and this is the API controller working for us, validating that the value that I'm passing in here is a valid habit status. So if I were to change this with 1, which is a valid status, you'll see that we'll get back a response. And if I update this with the habit status of 2, which is completed, then we don't have any such records in our database, and we get back an empty response. So let's say I want to apply all of these, including the query. I won't get back any response. Now let's omit the query value, and for example, let's include reflection, and now I only get back 1 response. It may also be worth exploring how EF Core translates queries like this into a SQL query. Let's say I omit the type and status filters and send a request. And if I take a look at the latest distributed trace that I have and open up the database query, I can take a look at the statement that was sent to the database. It only contains the filtering using our search term, which uses the name and the description columns. Now let's omit the search term and let's send a query using the type and status filters. We get back a response. And again, if I take a look at the latest distributed trace, which should be this query here, and open the query visualizer, you can see that we are getting a different condition. This time we're filtering based on the type and the specific value, as well as the status and its specific value. So you can see that EF Core can dynamically exclude the parameters if they aren't relevant for the query. The same applies for the type and status query parameters when they are null in the query that we send to the API. One more thing I want to show you before we wrap up this discussion about implementing searching and filtering is how to make your query parameters more maintainable. I'm going to create another DTO in the habits folder, and I'm going to call it habits query parameters. This can be a simple class or even a record, it doesn't really matter. And what I want to include inside is our query parameters. Now I had the search value, which I need to expose with a set because I need to update it. And then I had my 2 filters. One was the habit status, which was nullable. And let's give them a getter and an init setter, and also a habit type, which could be null with a get and an init setter. I did have the type defined before the status, so I'm going to just make them switch places. Now, what about my custom name for the search query parameter? I can still decorate this using the from query attribute and specify the custom name of my query parameter, and then I can use this object to bind my query parameters. So I can say from query, and this can even be inferred if you omit the from query attribute. And now I can use my object to encapsulate my query parameters. So here I want to say query search and perform this update. And then I'm just going to fix the remaining errors that I have in my code. This will be the query type property instead of the type argument. And the last one is going to be the query status. So now if I start my application and I send a query that includes a search term and 2 filters, and we land on this breakpoint, and I open up the query object, you can see that the search property has the correct value, and so do the status and type properties, which both contain my valid enums. So now I can execute my query the same as before and observe the results that I get back from my API. So this was a quick overview of how you can implement support for searching and filtering in your REST API, while also making it maintainable by using a custom object for binding your query parameters. In our next lesson, we're going to extend this functionality by implementing support for sorting our search results in ascending or descending order.